Both sections in Chapter 1 are pretty heavy on terminology, so that's what a lot of this video is going to be, but there are examples thrown in here too. The first couple of definitions are pretty pervasive all the way through the course. Generally, the population is the group that you're interested in. The sample is a subgroup, or a little piece of the population that information is actually collected from. What you try to do with that is you try to take the information from the sample and use it to say something about the entire population. That's what statistical inference is, which would include things like confidence intervals, hypothesis testing, regression models, essentially the bulk of what we're going to cover in the course. This picture comes from our book, and it goes along with the definitions on the previous slide. You take the information from the sample and use some kind of statistical inference to say something about the population at large. In this example, suppose a researcher studying student life wants to use this class to investigate financial aid at colleges in the U.S. The first thing we have to do is identify the sample. And it looks like in that sentence up at the top that the data is going to be collected from this class, so that's going to be our sample. Or more specifically, students in this class is going to be our sample. The next thing, the population, the entire group of interest. Based on that sentence up toward the top, it looks like that would be all college students in the United States. The last thing, can the sample data be generalized to make inferences about the population? Yes, but you won't get very good inferences about the population because the sample doesn't represent the population very well. Financial aid varies quite a bit from one school to another, and what we're going to end up with here is a sample that underrepresents a big chunk of the population, namely students who don't attend UK, and overrepresents a tiny chunk, students who do attend UK. With a bad sampling method, that's typically what happens, where you end up with one subgroup of the population really overrepresented, another group really underrepresented. One thing that's worth pointing out here is that it would be very easy and very fast to collect sample data this way, but any conclusion based on generalization of this sample data won't be very good. Ultimately, what you'll end up with is a conclusion that's not very accurate or one that's kind of distorted. Here we have another example where we have to identify the sample in the population. In that survey described up at the top, first we want to identify the sample, and it looks like it's those 369 working parents who were asked if they spend too little time with their children because of work commitments. The one thing I really want to point out here is that 369 by itself wouldn't be specific enough if you're trying to identify the sample. Something like 369 working parents is fine, and 369 working parents surveyed is about the best that you can do here. Just having the sample size is a common mistake. That's part of what you want, but that's not all of what you want. You do need more than that. The other thing that we need here is the population, and since our sample consists of a bunch of working parents, and generally the sample is a subset or a subgroup of the population here should be all working parents. Sampling bias. This is actually what's going on in that financial aid example. When the sample represents the population poorly, some members of the population are less likely to be included than others. When that happens, if you try to generalize from a biased sample to the population, you're going to get results or conclusions that are inaccurate. This picture is also from our book. The cloud-shaped sample is supposed to represent the good sample because it looks like the population. The diamond-shaped sample is supposed to represent a bad or biased sample since it doesn't look like the population. In general, you want to have an unbiased sample, not a biased sample. The easiest way to get an unbiased sample is to take a random sample, and the best place to start with techniques of taking a random sample would be a simple random sample. The way most people think about a simple random sample is actually the thing that's underneath the box, the idea of each individual in the population having the same chance of being chosen. However, the more correct definition is the one that's written in blue inside the box, where all possible samples of size n, where n is some positive integer, have the same chance of being the sample selected. Technically, what's underneath the box is a consequence of what's in the box, but if you think about it the way that it's written underneath the box, I think that'll be fine in a colloquial sense. There are a bunch of different ways to take a simple random sample. You could use a randomizer like randomizer.org, but the easiest conceptual way to understand it is probably the idea of picking names out of a hat. That's generally the correct idea, although if your population is something like all adults in the US, you're going to need a really big hat. In this example, we have a class meeting 3 times a week, and there are 10 different possible ways that that can happen. If the meeting days for the class were chosen using a simple random sample, what's the chance that the class meets Mondays, Wednesdays, and Fridays? Well, there are 10 possibilities, and each of those 10 samples would have to have the same chance of being chosen, so it's 1/10. Then what's the chance that the class meets on Mondays? Of those 10 possible samples, 6 of them involve a Monday. The only 4 that don't are the ones in the bottom row toward the right. So the chance that the class meets on Mondays is 6 divided by 10, or 0.6. If you repeatedly take random samples from the same population, the sample values will be centered around the population value, which might be a proportion, might be a mean, it depends on what you're interested in. If you repeatedly take non-random samples, the sample values will be centered somewhere else. There isn't a whole lot for me to add in here other than where this might be the case. For example, most Gallup opinion polls typically use phones to conduct surveys, and their population is typically all adults in the US. However, somebody who is 25 years old and doesn't have a phone would be part of the population, but there's no way for them to end up in the sample. This leads to the part that's at the bottom. Maybe the population really isn't all US adults. Instead, it's all US adults with phones. If you have a really big population, in a lot of cases, not everybody can be included in the sample. There are going to be some people where that's just not possible. The first thing to notice with this sampling method is how easy it would be to collect the data. And if this was how you were going to estimate how much students at UK study, would you expect the sample average to be higher or lower than the population average? Probably higher, because the sample consists of people who are already in the library. So the estimate probably won't be very good. It looks like the sample average would be kind of inflated. And this is called a convenience sample because it's very convenient to collect sample data this way. Everyone who ends up in the sample is in one place. You're going to the King Library, ask the people who are already there how much they study, so you'd be able to collect the data really fast. And that's why this kind of sampling method is alluring. It's why people do it, even though it's the wrong way to take a sample. It's really quick and it's really easy. Generally, with a convenience sample, whoever is collecting the data minimizes the amount of effort they have to put into doing the data collection. This is another poor sampling method. Suppose you want to estimate the percentage of UK students who are satisfied or unsatisfied, if you want to take the opposite perspective, with parking availability on campus. From the satisfied perspective, would we expect the sample proportion to be higher or lower than the population proportion? Probably lower, because in order to end up in the sample, people have to respond. They're essentially doing all of the work to end up in the sample, and who's going to be motivated enough to do that? People who are dissatisfied, angry, frustrated. Strong negative emotions tend to be good motivators. The people who are annoyed with having to take 45 minutes to find a parking space or park out by the football stadium, they're going to be more motivated, so the satisfied sample proportion would be lower than the population proportion. Or from the other perspective, the unsatisfied sample proportion would be higher than the population proportion. This is called a volunteer or voluntary response sample. And this kind of sample is one where effectively the sample picks itself. In this example, the person collecting the data doesn't really do any work. They just send out the email and wait for the responses to come in. The responders are the ones doing all the work here as far as data collection goes. This is another case where it's a bad sampling method, but it's a method that's not very labor intensive. You don't really have to put in a lot of effort to get your data, and collecting the data won't take very long. And again, just like with a convenience sample, that's why people do it. There are other forms of bias that are not related to the sampling method, including things like question wording, context, inaccurate responses, and non-response. Question wording is on this slide, where those two questions are really the same question. It's just that the second one itemizes the new government programs. And look at the difference we get between those two percentages. So it's possible for question wording to have a drastic effect. The way that context factors in here is that the question in the Ann Landers column essentially has a prompt in front of it, where it has the list of worries about parenting, various reasons not to have kids, and then there's that question. And really that one's kind of a mess, because not only is that prompt there, but it's also a volunteer sample. Then there's a Newsday poll that was based on a random sample of US adults with no additional prompt or no additional leading material. And we get another large disparity. Intuitively, looking at those numbers, the 91 makes a lot more sense than the 30. But then again, the 91 is coming from a random sample, and there's no leading material to push people one way or the other as far as how they're going to answer that question. Inaccurate responses. Both of the percentages on this slide are clearly wrong. There's no way 93% of the sample were better than average drivers. And the other one, 33% of the people surveyed had an opinion about an act that didn't exist. Really what that comes from is that it's hard to say, I don't know. Last, but certainly not least problematic, is non-response. A lot of polling data is collected over the phone. However, the response rate for a telephone poll is really low. It's typically less than 10%. Nowadays, it's usually about 8%. Non-response is the biggest problem with surveys that isn't directly related to the sampling method because the non-response rate is generally very, very high.